So different processing stations in a system, that is data flow technique is identifying different processing stations in a system, that is different processing stations in the sense those are called as the functions here. And once you are identifying your functions, then you can get those things, right? So that you can get those things, that is the items that are data that flow between the processing stations. That is, once you are identifying your functions, as if you are going for the same project of ATM, so once you are identifying your stations, that is functions. So what are the functions that ATM is going to have? That is modules, we can say. Those modules are either mini statement, balance inquiry, or pin generation, right? So like your Aadhaar updation, right? So all these things are your functions over here, and you are writing the code for the same functions. These items, that the data flow between processing stations, that is, one is going to be connected with the other is going to be connected with the other. That in the sense, what if you are clicking on the mini statement, the interface should display the mini statements itself. So if you are clicking on balance inquiry, the interface should display the balance inquiry itself. If you are clicking on the pin generation, it should display the pin generation itself. Okay. So it should not give no other functions apart from your the function which you are choosing. Okay. So then the data flow technique is a generic technique that is can be used to model the working of any system, because we are giving each and every flow of each and every item in a sequence. So when we are giving each and every flow in a sequence, it can be applied for the any of the model. Okay. So that is any of the system, not just for software systems. It can be applied for hardware systems. It can be applied for software. It can be applied for any kind of system. Whenever a project is there or wherever there is a necessity, you can go for applying your data flow technique, because you are giving the entire sequence, that is one step after the other, as a sequence. That is, the data is flowing from one step to the other step, or one node to the other node it is flowing. These are already in sequence with each other. So if the sequence is missing, then you are again checking with the sequence. If something is missing, whether it is in sequence or selection or iteration, you are going and checking back with the all the things. Then you are giving your solution. That is step by step execution. You are giving it for whether it is software project or hardware project. Okay. So a major advantage of this data flow technique is its simplicity. So whenever you are going to apply this particular data flow technique, it is going to be simple in nature. That is, so you yourself only giving this sequence. That is how the data is flowing. So if you are choosing your project as X, how your X project is starting and how your X project is ending. The flow you only defining. So data is following from the data is flowing from one start location till the end location. That flow you are only giving as in terms of your architecture or in terms of your strategy, that is step by step execution. So that is how it is going to be very much useful for the user, and it is simple in nature when compared with all the other things. Okay. So here also you can see the data flow diagram for a car assembly unit. So previously we have seen the data flow diagram or the control flow diagram of the same car example. Now we are seeing the data flow, how the data is flowing from one phase to the other phase. So what is our first phase, or what is our first step? Engine store, we are going and visiting. Then we are visiting your chassis store. From there, you are fixing your engine. That is fixing your engine. So from this, you are going to go for your door store, where the doors are being collected by the users, and then you are fixing your doors to the particular car. Then you are going to go for the wheel store, and again you are going to go for the wheels assembly. Then your complete car is going to be done with the help of your paint and with the help of your testings. Okay. So then we came to see up to the object oriented programming in the previous class as well. That is, in 80s, we were used to go for the object-oriented technique. So where an intuitively appealing design approach or natural objects such as employees, payroll registers, etc., occurring in a problem are first identified. That is, what are the objects that are there in the particular project, or what are the objects that are there in a given problem are going to be identified as objects. Based on the objects, how they are going to represent or how they are going to behave with the others is going to be identified. Then you are going to go for the proceedings. Okay, so that is, so the relationships among the objects. So if you are identifying two objects, what is the relationship between these two objects? Whether it is only one to one, that is only one connection is there in between those two entities, or that is objects, or one to many objects are there, or many to many objects are there. That likewise you are going to check. So say for example, if you are going to take your ATM card and your bank, so what is the kind of relationship that you are maintaining as a customer with your bank? One to one connection or one to many connection? ATM card and you are only one. Bank is also one. Okay, if you are maintaining an account in SBI Bank, one to one connection. If you are maintaining more than one bank, then you are said to be as a one to many connections. So you are identifying the objects, and then you are identifying the relationship between those objects, one to many, many to one, many to many. Like that, you are identifying the relationship amongst those objects, right? So such as composition, reference, and inheritance are determined, right? So whether any properties we are getting it from the past, that is from ancestors, or any properties we are acquiring from the past data, anything is carried forward like this, like that we are going to check all the consequences and all the things, and then we are moving forward for the objects. Then each object essentially acts as a data hiding, okay, a data hiding entity, right? So whatever that you are seeing as a project is different. Whatever the backend code is being written, that is also different. What we are saying, we are enjoying the fruits in the front end. So the coding part is being done by the so and so persons with lots of efforts, right? So each object is essentially acts as a data hiding entity. That is, data abstraction is going to be done in the objects. So whatever the code that you are writing for balance inquiry, we are enjoying the fruits for this balance inquiry, but the code is being not written by us. Okay. Then the object oriented techniques have gained wide acceptance because we are identifying the objects. They are simple in nature. So as the objects are identified, we are also identifying the relationship between those objects, right? And we are having reuse capabilities. That is, we can use n number of objects as multiple times. That is maybe once, twice, or whatever the requirement is there for the users, we can use again. So we are having simplicity, we are having user, that is reuse possibilities, we are having lower development time and cost, and we are also having easy maintenance. So with these features, we are gaining, that is object oriented techniques have gained wide acceptance. That is, most of the people are accepting the object oriented techniques because they are simple. Reuse opportunity is there, maintenance is there, robustness is there, and maintenance is also good enough, right? So this is how the evolution of your object oriented techniques have been come into existence. So initially we were having ad hoc, that is wherever we are having the problem, that problem we are choosing and we are giving the solution. Then came with the control flow based structures, where we were used to have the control based structure for the entire programs. And if we are having any issues with these control programs, then we came with the existence of data structure based techniques. Then we found few of the problems in data structure based objects as well. And then we came with the data flow based. And finally, we are with the object oriented one. Okay. So this is how it has happened from 1950 to 1980s. Okay. So we were used to have ad hoc, then control based flow came into existence, then data structure, then data flow, then object oriented. So you can take this diagram as a reference for your evolution of object oriented techniques. You can copy this diagram. Okay. So this is what we have seen from the morning till now is represented in the form of a picture. Finished? Finished? Right. Mm. 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 Ma, ma, slide end చేయలేదు. You can come and check. ఇక్కడ పైన అది రాకుండా పైన కోడ్ రాకుండా చూడండి. Right. So the evolution of other software engineering techniques. Now let us focus. Okay. So from the past 1950s to 1980s, so far we have seen. Now we will see the evolution of other software engineering techniques. That is, the improvements to the software design methodologies are indeed very conspicuous. Okay. So whenever we are speaking about the evolution of other software engineering techniques, so the methodologies, whatever we are using are conspicuous. Okay. So in addition to the software design techniques, several other techniques are evolved. So whatever we were used to have, those techniques are available. In addition to that, we are having several other techniques as well. Okay. So, such as your life cycle models, which is there in your second part of your first unit, specification techniques, project management techniques, testing techniques, debugging techniques, quality assurance techniques, software measurement techniques, and case tools. So, likewise, we are having several other software engineering techniques as well. So, out of which few of them are included in your syllabus. So, which is life cycle models, specification techniques, project management techniques, testing techniques, debugging, quality, software measurement. So, all these are included in your curriculum. Okay. So then we will see the differences between the exploratory style and the modern software development practices. So what were used in ancient days and what we are using at present or in 1999s. Okay. So use of life cycle models. So that is software is developed through several well-defined stages. So when we are using life cycle models, the software is developed through well, several well-defined stages. So what are all those stages are involving? That is requirement analysis we are involving with requirement analysis and specification, design, coding, and testing. So that was the older version of your software engineering, what we were used to have. The same process, again, we are using it for the future as well. So emphasis has shifted from error correction to error prevention. So before we used to have the error correction, whenever we were used to get any sort of errors in the lines of code, we were used to eradicate, that is, we were used to remove those errors. That is, error correction was there in the ancient days. And now we are trying to write the codes which are with error free. That is, error prevention is our main agenda. So modern practices emphasize the detection of errors as close to other point of introduction as possible. Okay. So we were using error correction and error prevention in the previous one. And in modern practice, what we are doing, we are detecting the errors close to the point of their introduction to as much as possible. So whatever the what sort of errors we are going to get, those sort of errors we are going to again remove, and we are taking care of those kind of errors are not going to be happen in further future. Okay. So then exploratory style errors are detected only during testing. Now we are focusing on detecting as many errors as possible in each phase of development. Okay, previously it was detected only during the testing. That is when the project is given for testing. At that time only the errors were tested. But as of now, we are testing it each and every phase. That is, whatever the errors that you are going to encounter in requirements phase, that you are identifying and you are rectifying. So if it is there in design phase, you are identifying and again you are rectifying. If you are having in construction phase, you are identifying and you are rectifying. If you are having in testing phase, you are identifying and again testing or removing those things. If you are having any errors in after deployment also, you are correcting and you are again giving the project back to the customer. Okay. So coding is synonymous with program development in previous one, right? So in nowadays, coding is considered only a small part of program. So earlier days, the coding was everything. In today's world, the coding is a part of development life cycle. Okay. So earlierly, one used to write the code or many used to write the code whatever is being written by those people is final. But now code writing is important. At the same time, testing without errors code is also important. So from past to present, what is changed? In past, code writing is everything or code is synonymous. Now it is considered as only a part of the program development method. So whatever you are writing, it is treated as only a part. Okay. A lot of effort and attention is now being paid to requirement specification. Now, what we are giving the priority? We are giving the priority to the requirement specification. When a customer is coming to a project manager or a company, we are focusing on the requirement specifications. What are the requirements for the user? How we can satisfy the customer? That part we are taking care. That is, requirement specification is playing the major role. Also, now there is a distinct design phase. Okay. So, satisfying the customer is important. At the same time, design is also important. Okay, that is standard design techniques are being used. So whatever the design that you would like to show it to the customer, if you are showing, if the customer is not satisfied, then you have to go for the design which is with standards or which is in standards only. Then only the customer is going to accept your design. Okay. So during all stages of development process, periodic reviews are being carried out. Okay. So whenever you are giving a project for the testing or whenever you are handovering a project to the customer, reviews are being conducted. That is periodic reviews, maybe weekly, 15 days, 1 month, 3 months, or 6 months. The reviews are going to be conducted, and based on those reviews, your project is being project is being analyzed, how effective it is. Right. So now what is happening? So now software testing has become systematic. So standard testing techniques are available for testing the project. Now they are going for testing instead of manual or 1 week, 15 days, 1 month, 3 months checking. You are going with the standardized testing techniques for testing your complete project. Okay. So there is a better visibility of design and code, right? As of now, in the past, very little attention was being given to the productivity, quality, and consistent documents. Okay. So nowadays, what is happening? Visibility and designing the code is playing the major role, that is giving the priority to them. And in olden days, it was only a little attention to the good quality or producing the good quality of consistent documents. Okay. So because of good documentation, fault diagnosis and maintenance are smoother now. Okay. So because of those things, the fault diagnosis and smoother things are going to be happening now. So several metrics are being used to help in software project management quality assurance. Okay. So this is the thing which is happening right now. So projects are being thoroughly planned by using the estimation, scheduling, monitoring mechanisms, and use of use cases. Okay. So previously it was with the help of life cycle phases. Now it is before we go for the life cycle phases only, they are going for the estimation, scheduling, costing, monitoring mechanisms, and all those things. We are planning and we are going for the use of use case tools or case tools, we can say. So these are the differences between your exploratory lifestyle and modern software development practices. Okay. So clear so far? Ma, is it clear so far? So what we have seen? We have seen only the software evolution from the 1950s to till date, and what are the differences of doing a project in olden days and in current days. What are the metrics that we are taken in the previous days and in current days only we have seen so far. Is it clear? Clear. We are not getting any response from the backbenchers. Same case. Okay. Ma, clear? You are still in the classroom? Okay. So is it clear? That is whatever we have seen is in the past, what was the procedure of a project carrying documentation and how it has been done from the initial stage to the final stage, and what are the futures that we are having as of now, that is in 19th century or in 20th century, what are the practices that we are focusing on, right? So once we are clear with these things, we can move on to your SDLC. Okay, software life cycle. So what do you mean by software life cycle? Software life cycle. So what do you mean by your software engineering? Software engineering. Software engineering. So it is a systematic approach or systematic arranging your techniques, past experiences, methodologies, and guidelines. Okay. So what do you mean by software life cycle? Software life cycle. So this one we can relate it to our daily routine. Okay. So the process which we are adapting from the morning till late night is our daily routine, right? So similarly, software is having its process to continue its progress. That is its process to develop, design, test, monitor, and do all the activities related to the project. It is also having a process, that is procedure. Okay. So that is our software life cycle is. Okay. So the software life cycle or the name itself is giving us the software process, we can say. So when we are speaking about the process, it is going to be series of actions or discontinuation of actions. When you are speaking about the process, is it going to be continuity of actions or discontinuity of actions? What kind of action it is? Continuity or discontinuity? Continuity. Fine. So series of identifiable stages that a software product undergoes during its lifetime. So software process is a process which a series of identifiable stages. So stages of whom we can say, whose stages we are speaking about. All these stages are related to software product. So if you are speaking about any project, those are related to project. Otherwise, these are related to your software product. The software product may be your project, or the software product may be your item, or software product may be your hardware device, or the software product may be your software device, or mixture of all these things. Okay. So undergoes its lifetime. Okay. So during its lifetime, starting from the beginning till the deployment or after deployment, what is the process that is adopted by any project or product is called as the software life cycle. Okay. So it is having several set of process, right? So those actions we have seen in the previous class. So what are those actions? First one is your feasibility study. So you have drawn one diagram. So where you are having all these phases or all these steps, right? So have you taken that particular diagram where you are having all these things? Have you drawn the diagram? So when we are seeing about the data flow or flow control structure, you have drawn the diagram, which is indicating feasibility study, right? So requirement phase, requirements, analysis and specifications, design, coding, testing, and maintenance. Have you taken this particular diagram in the previous session? Right. So it is also available in the previous session. So where it is giving us the complete software product. Okay. So it is undergoing the following steps or stages in its lifetime. That is, software project is undergoing these steps in the lifespan of that particular product. So first one is feasibility study. Second one is requirements analysis and specification. Next is design, coding, testing, and maintenance. So how many stages it is undergoing? How many stages it is undergoing? Six stages it is undergoing. Starting from the feasibility study till the maintenance, it is undergoing six different stages. Okay. So software product undergoes six different stages in its lifetime. Right. So what is there in feasibility study? What is there in feasibility study? According to our previous example, what is there in our feasibility study? In feasibility study, what you are looking or what you are taking care of? A particular product or project. What you are looking? So you are having projects. Do you have project marks for your labs? Project marks, separate 5 marks or 10 marks. Are you having 10 marks, right? 10 or 5? Internal, how many marks? 40, 30. Internal, total internal, 30. So out of which theory, 30 marks or 70 marks? Final. Lab internals, 40, 60 or 30, 70? 30, 70. So separate marks are given for projects. Wow. Are 23 or 22 regulation? 23. ఇంటర్నల్ మార్క్స్ ఎన్ని మొత్తం 30. ఎన్ని క్వశ్చన్స్ ఇస్తారు, ఎన్ని రాయాలి మీరు? ఓకే ఫైన్. సి, సో ఫర్ ఎగ్జాంపుల్ యు ఆర్ గివెన్ ఏ టాస్క్ ఆఫ్ సబ్మిటింగ్ ఏ ప్రాజెక్ట్. ఓకే, ఒక టాస్క్ ఇచ్చినారు. యూ హ్యావ్ టు సబ్మిట్ ఏ ప్రాజెక్ట్ ఫర్ సాఫ్ట్వేర్ ఇంజనీరింగ్ ల్యాబ్. సో దో ల్యాబ్ ఈస్ నాట్ దేర్, imagine that the lab is there. So you are asked to submit a project in software engineering. So with latest topics. So the latest topics may include AI, blockchain technology, machine learning, deep learning, right? So likewise, few concepts are given. You are asked to pick one topic for your project. What is the first step that you are going to do? So you are available with multiple options or only one option? No. First, you have not picked your area, right? You have not picked your module A, ML, DL, or BCT. You have not fixed to your domains. First, multiple options are there or only one option is there? Only multiple options are there, only one option. Well, last, multiple or one? Sorry? Multiple options are there. So when you are having multiple options, how many options you have to choose? Only one option you have to choose. Okay, say for example, you have chosen the concept called, sorry, your module called AI. That is your domain is AI. So the complete class is taking projects. Some people are taking on AI, some people are taking on DL, some people are taking on blockchain technology. That is the example. Okay. So whoever has chosen AI, okay, so they need to go for the AI related concepts and they have to go for undergo their project with the help of AI tools, right? So module is being chosen, that is domain is fixed, that is AI. So whether you are going to search for AI related topics or not, topics. So you have chosen AI as your domain for doing your project. Have you fixed your title? Titles are fixed. Titles are fixed. Title fix చేసుకున్నారా? Domain is fixed, that is AI. Titles are fixed. Titles, you have fixed your titles or not? Not yet fixed, right? So still we are in search of your topics which are related to your AI concept. Okay. So imagine one topic is already chosen. One topic is already chosen. Out of multiple options you are having, one topic is chosen. Okay. Topic is chosen. Right. So that topic, whatever the project that you are chosen, that you have chosen, no? Is it the first time that you are doing the project, or some part is already available in the market? So you have chosen a domain with AI, you are choosing a title, that is one problem you are identifying, and you have identified your problem. That problem, whether you are doing it for the first time or the related information is already available in the market, like your search engines, chat gpt, google, or wikipedia, anywhere you are going to find your title related matter. You are going to find any related matter. Can we find or not? We can find, right? So that process, when you are choosing your title and when you are entering your topic into your search engine, it is going to give us multiple options like papers. Whoever is published their papers, those papers will come into play. So if the matter is related to some other college or some people have done the project related to your topic, that topic's information that it is going to display. So what you are doing, what we are doing generally or actually, so we are finding out what are the resources that are already available for this particular project. Okay. So that study, complete study, we are going to say it as the feasibility study. Okay. So what we are doing, we are choosing the topic. We are choosing the domain. We are choosing the topic. We are entering the topic into the search engine. We are getting the entire information related to that particular topic. We are keeping or we are copying the same information into a document, and we are keeping it aside with names. That is, so if you are typing topic one, that is some topic is being typed. If you are getting n number of outputs, right, as display, so then you are going to choose, that is, you are going to click on the first output, and then you are going to write the concept what is there in the first link. Then you are writing the author name, so he has contributed so and so information to this particular topic. Then you are going to click on the second link, third link, fourth link, fifth link, and up to 5 to 10 links you are going to click, and you are going to summarize the entire topic of yours into the form of a documentation. That process we are going to say it as the feasibility study. Okay. So after your feasibility study, right? So after your feasibility study, you will come to a conclusion that this is not the new project that we are doing, right? So the project is already existing, or a part of project is already existing. So we are going to identify the gaps in between those outcomes. We are going to identify the gaps in between those points or those papers, and then we are going to go for your solution for that particular problem. This is generally what is happening in the market. Okay. So when you are asked to do a project, you are choosing a topic, then you are going for what are all the things that are required for that particular project you are gathering. Then you are going it for the requirements analysis. That is, so if the customer is coming to you and you are saying n number of inputs I want, you are going to write all the n number of inputs. Then you are going to analyze. So is these n number of inputs are necessary for doing the project or not? You are going to analyze, and based on your analysis, If they are necessary, you are going to keep all the n number of requirements. Otherwise, what we are going to do, only specific required requirements you are going to keep, and remaining all things are going to be omitted out. Okay, so that process we are going to do it in the requirements analysis and specifications. We are going to specify the information, and we are going to analyze the information, and again we are going to specify your complete information related to that particular party. Okay, so whatever the requirements are gathered over here, whatever the requirements are finalized over here, for these requirements you are going to go for a design part. Okay, based on these requirements gathering, you are going to design a particular pictorial representation which is depicting all these requirements. That is our design part. That is design stage. So once the design stage is completed, so whether it is hardware product or software project, or it is mixture of both. So once you are identifying your software product, sorry, that is your product, how the nature is, then you can go for your coding. Okay. So if it is related to software, you are going to write the entire module's code in your software language. So if it is a mixture, you are going to use the hardware kit and software kit, and again you are going to write the code, and you are going to interface these coding parts. Right. So once the coding is done, so whether it is correct or not, we are going to test with the help of testing. Right. So if testing is also being passed, then you are going to deploy your project to the customer. Right. So once you are deploying the project to the customer, again, if any mistakes are there, that is any errors are coming, the customer is again coming back to you and asking for the what? Error correction. Right. So that process you are calling it as over here maintenance. Or once the project is deployed to the customer, how it is working, where it is there, and what are the futures of those particular products which are being shared by the user to the end user into the market. Everything has to be taken care with the help of maintenance. Okay. So this process or these stages are going to be undergone by a complete software product. Okay. So here that product we are going to say it as the software project. Choosing from the topic till the completion of the product, that is completion of the project is our life cycle process. That is software life cycle. Is it clear? Software life cycle process. Clear? Ma, right. So starting from the first stage till the last stage, whatever the process that we are applying is our software life cycle. Right. So here is also we are having some models for life cycle. Right. So not all the phases or all the models are going to give us the similar kind of output. So it is going to, some will give us the continuous approach, some will give us the modulus approach, some will give us the different kinds of approaches. So here we are having life cycle models. A software life cycle model or process model is a descriptive and diagrammatic model of software life cycle. So what that we have already seen when we are discussing about all the phases. So the project team or the company has to show the architecture, that is design. Then only the user is going to accept the model. Then they are going for the writing of code. So what we are saying over here, a descriptive and diagrammatic model of software lifecycle is the software lifecycle model. Description has to be there, diagram also has to be there when we are going for the software lifecycle model. So it identifies all the activities required for the product development. So if you are choosing software product, so it should give us all the related aspects. Okay, what are the functionalities that are needed for doing the things? What are the non-functional requirements, functional requirements, and all the other aspects that are included for giving the product as a project has to be taken care with the help of this identification of your activities. Okay, so it establishes a precedence ordering among the different activities. So which one has to be coming first? Which one has to be coming next? All these things are to be noticed when we are going for the life cycle models. So it divides life cycle into phases. Okay, so what the life cycle model is doing? It is dividing life cycle into phases. That is, whatever we have seen, the life cycle stages are again going to be treated as the phases of the life cycle. Okay. So several different activities may be carried out in each life cycle phase. For example, the design stage might consist of structured analysis activity followed by structured design activity. So for example, if we are dividing those stages into different phases, what we are going to do? If we are categorizing it into life cycle phase, that is different activities, design, if you are going for the design stage should be containing the analysis of the activities and the design quality. So the diagram should be there and the assessment of this diagram should be there. That is, the quality assessment should also be there when we are going for the design stage as an example, right? So why model life cycle? That is, why life cycle models? Why we are going for life cycle models? Why we are going for life cycle models? So you are already having different stages like feasibility study, design, deployment, like your feasibility study, requirement analysis and gathering, design, coding, testing, maintenance, and all those phases you are having already, right? So then why you are going for your life cycle models? Okay. So that process we are having throughout the entire life cycle, but it is not going to be same for each and every model that we are going to apply. Okay. Right. So, but the final output will be same for each and every model that we can assume. Okay. So why we are going for this particular life cycle model in the sense a written description forms a common understanding of activity among the software developers. So why the
modern.
Is it clear or not? Lunch తర్వాత మంచి నిద్రపోతున్నమాటరా? Yes, is it clear? I'm not getting any response. అయితే అర్థమై ఉండాలి లేకపోతే ఏం అర్థం కాకపోయి ఉండాలి. Right. So then we can move on to the same again life cycle model, right? So we are seeing the nooks and corners of life cycle model, right? So a life cycle model defines entry and exit criteria for every phase. Okay. So what are the phases of life cycle model of waterfall model? Communication, that is requirements gathering, planning, design, coding, right? So testing and deployment. So whatever the process is there, it is defining communication phase. It has to start from the so and so things and it has to end up with so and so things. So then planning, how the planning has to be and how the planning has to end. So then designing, how the designing part has to start, how the designing part has to end. Likewise, each and every step, it is going to have its entry point and exit point. Entry point will be there and exit point will be there. That is defines for the each and every phase. Okay. So a phase is considered to be complete only when all its exit criteria are satisfied. Okay. So you can enter into the phase anytime. That is, you can enter into a phase after completion of the full satisfaction of first phase, then only you are allowed to enter into the second phase. That is, once the communication phase is finished of a particular project, then only you are allowed for entering into the planning phase. Once planning phase is also being completed, then only you are allowed to enter into the next phase of designing phase. Once the designing entry and exit satisfied, then only you are going to go for the coding part. Likewise, you are exiting from each and every phase after satisfying each and every criteria or each and every conditions. That is the intention. Okay. So the phases exit criteria for the software requirement specifications phase are. So software requirement specification in the sense document is complete, reviewed and approved by the customer. So when your SRS is going to be completed, that is software requirement specifications or requirements gathering is going to be set to be as finished. When you are going to say your gatherings are completed, first phase of your waterfall model is finished. When you are going to say it, so customer is coming and giving the project. So if he is satisfies with your efforts or without satisfying his efforts. So when the customer satisfies for your efforts, then he is going to accept your project. Otherwise, he is not going to accept your project, right? So then that is first he is going to come to you. He is going to give you a brief of what he is expecting. So once he is giving a brief of what he is expecting and you're writing all those points in your own words. And then once all the requirements are being done, you came up with your final list, right? So out of all these things, you will be satisfying the customer with limited number of requirements. That is unlimited number of functions you are going to give, but limited number of things only you are going to give. Okay. So then once you are satisfied with that is documentation is complete for these requirements and reviewed. Who is going to review? Who is going to review the requirements? Customer is again coming to you and he is going to review the requirements with the help of his friends or with the help of the genius people, or he himself is going to come and verify your requirements, whatever he is intended to have, whether you have kept it or not. So if you are satisfying the customer, then he is going to approve those requirements. Okay. So communication phase is going to complete, that is SRS is going to complete when the documentation is being done, when it is being reviewed by the customer and when it is being approved by the customer. then only you can go for the next phase of your planning. Okay. So a phase can start only if phase entry criteria have been satisfied. Okay, you can enter into a criteria when the phase entry criteria is satisfied. That is, so once you want to enter into the second phase of your life cycle model, the first phase exit has to be satisfied. Then only you are allowed to enter into the second phase. Otherwise, you are not allowed. Okay. So it becomes easier to software project managers to monitor the progress of the project, because entry point he is fixing, exit point also he is fixing. So while when you are entering into a project, when you are entering into a project, and when you are entering into your life cycle phases, when you are completing the exit of the previous phase. Okay. So once the previous phase exit is finished, then only you are allowed to enter into the next phase entry. Okay. So then it is giving the project manager to monitor each and every project. Very simple, right? So when a life cycle model is adhered to, the project manager can at any time fairly accurately tell at which stage the project is, right? So is it true? Can a project manager say where the project is as of now or as on date? Can he able to tell to the customer? Can he able to tell? So because he has completed only the first phase, he can deliver to the customer. First phase is completed. So if second phase is completed after few days, he can say that the customer second phase is also completed. So what is the intention over here? Whenever we are following the life cycle phases, that is life cycle model, then it is giving the task for the manager to tell about the project, where it is, whether it is in design phase, coding phase, testing phase, or any of the phases, to the customer very easily with the help of life cycle phases. That is life cycle model. Otherwise, it becomes very difficult to track the progress of the project. So imagine there are no life cycle models. That is no sequence of execution. Can you say what is the status of your project? If there are no life cycle models, can we say, or can you say what is the status of the project? Imagine there are no life cycle models. Is it possible? No, right? So because we don't know where is the project is stopped. Okay, whether it is stopped at the beginning stage or after the first stage, second stage or third stage or final stage. When can we know? When you are following a particular cycle model or cycle. Okay, what is the cycle is associated with that cycle, you have to know. Otherwise, the progress is not going to be monitored, or progress is not going to be shared with the users. Okay, so this usually leads to a problem known as 99% complete syndrome. Okay, so this also leading to a problem called as 99% complete syndrome, because whenever a customer is coming and asking what is the status, the manager is saying up to here it is completed, up to here it is completed, up to here it is completed. So what the customer is expecting, he is expecting 100% completion of the particular project, but it is not yet fully completed. So here we are going to say it as 99% complete syndrome. Whenever the customer is coming and asking, we are saying it is completed. How much it is completed? This much only it is completed. We are not going to say any kind of percentage or not. Okay. So this is what is happening in day-to-day life. Okay. So many life cycle models have been proposed. We will confine our attention to a few important and commonly used models. Those models are your classical waterfall model, iterative model, evolutionary model, prototyping model, and uh, spiral models, right? So we are not speaking about each and every model, but we are speaking about only few models which are included in our syllabus. Those are classical waterfall model, iterative models, that is iterative waterfall model, evolutionary models, prototyping models, and spiral models. Okay. So these are the topics which are included in our concepts, that is in our syllabus. So up to here, is it clear? So we came to a place where we are having some end part for the discussion. Is it clear? Ma, each and every time I need to focus on last bench, last bench, last bench, or you are going to give response. Is it clear? So what are the topics that we have seen so far? And now you will say the topics and I will say what we have seen in those topics. First one, yeah, now one can stand and deliver what we have seen. So first concept, whatever we have seen is, what was the topic that we have seen in the beginning? What is software or software engineering? Okay. Then why is software engineering is important? Then, sorry, then what was the topic that we have seen? Engineering practice, why it is important, what is happening, and what are the practices that we are adhering to. Next, then what we have seen? Then we have seen the futures of software and the crisis of software. What are the reasons or what are the factors that are contributing to the crisis of software? Sorry. Then we came to see the program versus software products. Then, sorry, computer system engineering. Computer system engineering, what is the process that is taking place in computer system engineering? What are the steps that we are following? And what is happened in the past? And what is happening up to 1999? That part we have seen. So what is happening in 1950s? What was happening in 1950s? How the computer system engineering was? 1950s. It was assembly language. Then 1960s it was high level language where you are came up with your COBOL, Fortran, and all those things we have came up with all those things. Next, sorry, structured programming. Okay, so before structured programming, what was there? Control flow based diagrams are there, data flow diagrams are there. So based on the drawbacks, we came to the structured programming, where structured programming is having which language? Structure one is having some three steps like sequence, selection, and iteration. Then, then we have seen the data structure oriented design in 1970s. Then, sorry, data flow oriented design. Then we have seen the differences between previous and the present trend of the software. And then data flow model of the software we have seen. Next, then we have seen the evolution of OOPS, that is object oriented paradigm. Next, we have seen the evolution of other software engineering models. Then we have seen the basic concept of your software life cycle, where you are having, that is software product is having how many stages? 6 stages, starting from feasibility study to maintenance. That is feasibility study, requirement specification and analysis, then design, coding, testing, maintenance. Okay, you are having all those stages. Then we came to see the life cycle models and what are the what is the importance of life cycle models in day-to-day life. Then what is the process that is happening with the current projects and what is the happening with the what was happened with the previous projects that we have seen. Then anything else? Anything else apart from all these things? So just you can check with your syllabus. We have covered your first part. Okay. So in unit 1, you will be having two parts, right? Before the SDLC, that is software development life cycles, we have covered every concept from the beginning till the last one. Okay. Syllabus. You are having syllabus. So that is your evaluating software development projects. We have seen exploratory uh, style of software development. We have seen emergence of software engineering. We have seen notable change in software development practices. We have seen computer system engineering. We have seen, and then we have started the concept of your software lifecycle models. There we have seen the basic concepts. Okay. So up to basic concepts we have covered. So if it is okay, we can move on to the further proceedings of the waterfall model or SDLC. Up to here it is clear. We can quickly summarize and we can go for the next one, right? So here the snapshot of what we have seen are the few important concepts what we have seen so far. So software engineering is a systematic collection of decades of programming experiences together with the innovations made by the researchers. That is the thing we have seen. A fundamental necessity while developing any large software product is adoption of life cycle model. So which model has to be chosen? That is very, very important when you are going for the adopting your software life cycle, that is product, right? So adherence to a software lifecycle model helps to do various development activities in a systematic and disciplined manner. This is also we have seen. Also makes it easier to manage a software development efforts. This is also we have seen, right? So all these things are in reference to your textbook, which is called as your Fundamentals of Engineering, Rajiv Mal. Okay. So this is your prescribed textbook according to me, right? So from this book only we have taken all these concepts. Okay. So this is the first part of your complete syllabus. Clear? Move on to the next one. Shall we go? Right. So once we are clear with these previous topics, we can quickly move on to your software life cycle. So what is software life cycle? Bit fast or slow? How we are moving? Slow or moderate or fast? వెళ్తున్నామా fast sorry, fast or slow? Medium. Okay. So then you are able to catch up with us. Then it is fine. Right. So what do you mean by life cycle? What is life cycle? No, what do you mean by life cycle? What is life cycle? stages of product or software product we are going to say. Okay. So what do you mean by software life cycle? So these are the phases of software itself. Okay. So the software water Amma. ఎదురమ్మా అదేరమ్మా అదే వాటర్ అమ్మా. So what is software life cycle? It is the process of the complete process of the software is your software life cycle, right? So what are the phases or what are the steps that are associated with the software life cycle? Let us say right now. Okay. So a life cycle of a software events, the series of మళ్ళీ పోయింది. A life cycle of a software, okay, software events, the series of identifiable stages through which it evolves during its lifetime. So what is software life cycle? So whatever the phases or whatever the stages it is evolving throughout its lifestyle, sorry, throughout its lifetime is called the software life cycle phases or software life cycle. So it is having few stages like inception stage, development phase, operation or maintenance phase, and retirement phase. Okay. So that is inception, elaboration, deployment. Sorry. So according to your textbook, inception, elaboration, deployment, coding, deployment, and testing. Okay. So inception stage, development stage, operation phase, and retirement phase. These are the new terminologies which we are using. But we have to go according to your textbook. Whatever the phases that the faculty has given at the beginning of software life cycle, those only you have to follow. Okay. So this is the summary of what is there in those particular life cycle phases. Okay. So in inception phase, what you are doing? Inception phase. That is, you can say it as your communication phase. What is happening in communication phase? What is happening in communication phase? Communication or requirements gathering. So customer is coming to the company and asking for the his needs for the so and so project. Okay. So that phase, that steps, those activities, whatever related to the requirements gathering and SRS finalization are kept in the inception phase. Okay. So next one is elaboration phase. What you are going to do in elaboration phase? So once the requirements are gathered, what you need to do? Requirements are gathered. Then what is the next step? No. So after requirements gathering, what you have to do? You have to go for planning. Then you have to go for designing. Then you have to go for coding. Then you have to go for deployment or testing. Okay. So this should be the flow, life cycle. So first phase is inception phase, elaboration phase, right? So then that is communication, planning, design, implementation, and maintenance. Right. So like this. Right. So next we have to go for elaboration and development phase. Then once it is completed, then we have to go for coding, designing, and testing. Then we can go for the maintenance. Okay. So this is what is there in our software life cycle. So then what is SDLC? Software. So then what is SDLC? Then what is your SDLC, software development life cycle? What do you mean by SDLC, software development life cycle? Is it also going to have the phases, or it is not going to have the phases? So what is your SDLC model is? Is it going to have the phases? So what are those phases? Mm, Phases. I am asking about the phases, not the models. Okay. Uh, Sharply and smartly, you are saying the answer as these models, but I am not asking about these models. I am asking about the phases. మీరు షేరింగ్ లో పెట్టినారు కదా, షేరింగ్ లో లేదా? Then they can say no. అట్లా రావట్లేదు. What are the phases for software development life cycle? How many phases will be there, and what are they? SDLC. What are the product stages? 6 stages you are having, right? So out of which you have to write 5 phases in SDLC. Okay. Even if you are writing 6, that is also fine. So you have to write from the starting phase. That is your, what is the first stage of your project? Planning. Before communication, you are coming for planning. Then your project is successful or failure. So first you need to gather the information, that is requirements gathering. Then, then you are going for planning. Then once the planning is done, you are going for design. Once the design is done, you are going for construction. Once the construction is done, you are going for deployment. Okay. So this is your SDLC life cycle. Okay. So once you are clear with the gatherings, that is requirements specifications or requirements analysis is done, then you are going for the planning, what is to be done furtherly. Okay. So then you are going for design. So if the design is okay and approved by the customer, then you are going for coding part. Then again you are going for your next part. Okay. So that is your SDLC. Okay. And SDLC graphically depicts the different phases through which a software evolves. It is usually accompanied by a textual description of the different activities that need to be carried out during each of the phase. Okay, what are the things that need to be carried out at each of the phase are going to be indicated in that particular SDLC phases, right? So then the purpose. What is the need for your SDLC? Is there any necessity? Or we can directly go for, without any hesitation, can we go for direct design without gathering the information? Can we go for design directly? No. So if you are going for design directly after requirements gathering, or if you are going directly for design, then what is the status of the project? What is the status of the project? Successful or not successful? Not successful, because we are not following any systematic way of developing the project. Okay. So here the purpose of SDLC is to provide the structured approach to software development. So whatever the process that you are following, whatever the development that you are doing, that has to be in a systematic approach. So if you are not following any systematic approach, then our project is not going to be successful in the market. So then, to ensure quality, efficiency, and predictability in the software development process is our next process. That is to ensure the quality of the product, what we are designing or what we are developing and what we are deploying. So what is the efficiency of the project or product, and what is the predictability of that particular product in the market in future? All these things are going to be kept in view when we are going for the purpose of the SDLC. Okay. So now you can say the answer. What are the various SDLC models that you are having? What are the SDLC models that you are having? So waterfall model, iterative model, spiral model, and V model. So out of which, what is your waterfall model? So here you can see requirements analysis, design, implementation, testing, deployment, maintenance. These are your SDLC phases. Okay. So benefits of SDLC phases or SDLC models we are already discussed. Once I will go through, just you can see and listen. Okay. So the benefits of SDLC models are improved project planning and management. So what is the first benefit that we are going to get? We are going to get the improved project planning and the management. So once you are following the procedure, that is systematic approach, the manager of a company can tell the customer where the project is. That is whether it is in first stage or second stage or in the which stage? First stage, second stage, third stage, fourth stage, or fifth stage. What is the current status of the project can be easily identified with the help of the improved project planning and management. That is the first benefit which we are going to get. And second one is enhanced quality and reliability of the software. We are going to get the enhanced quality. Okay. So because we are assessing at each and every phase. Once the first phase is done, we are checking with the entry point, we are checking with the exit point. So if the exit point is satisfied for this part, then only we are moving on to the second phase entry. So if entry is satisfied and exit is also satisfied by the second phase, we are moving on to the third phase. So if entry and exit are satisfied, then only we are moving on to the next phase. So if everything is perfect, then only we are moving on to the final phase and we are deploying the project to the customer, right? So here enhanced quality and reliability of the software is taking place with the help of the entry and exit point checkings, right? So next one is the better risk management. We are having better risk management because if one phase, that is first phase, entry is accepted and exit is not accepted, that is if you are having any issues over here, what we can do, we can rectify all these errors. Again, we can go back to the first one, or else we can rectify all these errors and we can move forward to the second phase. Because entry point is fixed and exit point is also fixed. Because we are having no errors in first stage, we can move on to the second one, right? So we are having better risk management. So whatever the risks are there, that is whatever the errors are there, we are going to remove them at a frequent level, right? So we can clear documentation and communication among stakeholders. Okay. So we can go for the clear documentation and communication with the stakeholders. That is, who are the stakeholders over here? The customers are the stakeholders, or the persons whom the customer is getting, they are the stakeholders. Okay. As of now, only the customer, right? So the predictable and manageable timelines and budgets. So once you are going with the SDLC process, you can easily assess the amount that you are spending on a project and what is the status of the project and what you are gaining based on your project. All those things you can betterly understand and all those things you are able to get with the help of these SDLC models. So these are the various benefits that we are getting out from the SDLC models. Clear? Clear? Now can you able to see? Only few people, I think. Previous slides were very good enough. These slides we could not able to zoom. Okay. Everyone can able to see the slides. Last persons, you could able to see. Ma, is it visible? No, right? So you can come forward and sit. I think your friends have given the sharing access as well. Okay, you can watch it through the sharing as well. Okay, right. So then we will see the difference between a process and methodology. So what is a process and what is a methodology? What is a process? What is a process? What is a process? So what is your life cycle process? Step by step completion of your project is your life cycle process. Okay. Then what about the methodology? So methodology focuses on the detailed steps that specifies within a sorry the focuses on detailed steps within a specific activity. Okay. So when you are focusing on your process, it is giving us the brief of the entire process. When you are focusing on the methodology, it is focusing on the detailed steps within a specific activity. Okay. If you are speaking about requirements gathering, that is going to be associated with the methodology of requirements gathering itself. So if it is going to be with the help of any other stage, it is going to be the methodology of that particular stage only. Okay. So when it comes for the process, it is giving us the entire process of what we are doing and how we are doing. Right. So the first one is your waterfall model or classic waterfall model, we can say. So what is waterfall model? So this is what you are having in your textbook, right? Waterfall model. So first phase is your feasibility study, requirements analysis, design, coding and testing, integration and system testing, and maintenance. So this is the picture which is taken from your textbook itself. So if you have seen your textbook, so this is what you are having in your textbook, right? So waterfall model is containing all these phases, right? So starting from feasibility study to maintenance. So what you are doing in feasibility study? What you are doing in feasibility study? See, determine financial and technical feasibility. Okay. So what the feasibility study here over is giving us, it is giving us in with respect to the technicalities and the with respect to the financial. That is how much amount we are keeping in the project, what is expected, and what is going to be the useful fund. And collect and analyze basic information about input data. So what is input data? What is the input data? What is the input data? The data which is related to your project is your input data. Okay. So that has to be collected and analyzed basic information about your input data, required processing and output data. So whatever is the topic is being chosen, that you have to collect the information, that is basic information, input data, how you are processing it, and what is the output that you are expecting or getting. So develop an understanding of the problem. So how we are understanding the problem? How we are understanding the problem in feasibility study? How we are understanding? So how you are understanding the feasibility? That is how you are understanding your problem. What you are doing? What is the process that you are doing in feasibility? So there is a search engine. and you are typing your title. So this title or with this topic, it is displayed with multiple number of options. So based on the multiple number of options, you are again storing the information for first, second, third, fourth, fifth, sixth, like that you are storing the information. That is, you are keeping the information aside. So based on these information which you are having, you are identifying the gaps. You are identifying the gaps in between these inputs and outputs. Then you are coming to a conclusion of what is your problem is. That is, what is your statement, right? So once the statement is fixed, then you are going for your solution strategies. Okay. So that is the process that you are doing in the feasibility study, right? Now, what you are doing in your feasibility study? What you are doing? Feasibility study. What you people are doing? Sir, initially you are identifying your topic or title. You are giving it to your search engine. Search engine is giving you multiple options. Again, you are taking the information. You are identifying the gaps, right? So then you are trying to fill out those gaps. That is, from those gaps, you are identifying your problem as your problem statement or project, and you are giving the solution for that particular project. That is, whatever the topic that you are identified. Okay. So then you are going for the requirements analysis and specification. So in requirements specification and analysis, what you are doing? What is the task over here? Requirements gathering and analysis. Topic is being chosen. We have to gather the information related to that particular topic, and we have to fix whether it is useful or not for that particular topic. So if it is useful, then you are keeping the information into your project. If it is not useful, then you are omitting it out. So that is the process that we are doing in requirements specification and gathering. So requirement specification and analysis. Then next step you are going for. Next step what you are going for. So then you are going for your planning phase. Okay. Planning. Then you will be going for your design. So what you are doing in planning, you are drawing a rough picture or architectural diagram for this particular project, whatever you are thinking. That is topic. So once this architecture is done, then you are going for the design of that particular architecture. That is, planning is done, then you are going for design. Then after the design is finished, that is the customer is approving, then you are going for the coding and testing, right? So then you are going for your integration and system testing, and then finally you will be going for the maintenance. Okay. So that is starting from the requirements gathering till the deployment, you are having various stages, that is various steps to be followed to complete your project. These are all called as your waterfall model steps. Okay. So all these steps are starting from the feasibility study till the maintenance. So at each and every step or at each and every phase, we are following set of actions. So those actions, what we are doing is in these particular phases is our complete SDLC model of waterfall. Okay. This picture is very, very important. Okay. So in picture, you can show what is the entire process of your waterfall model. You can copy the figure. If it is already available, just inform me. Is it already available? Available? If it is not available, just you can copy the figure. If it is available, we can move on to the next one. PPT yes, Mara. Note slow, Rama. Note slow. In notes. Is the figure available in your notes or in your mobiles? Mobiles not encouraged. you can draw it in the notes. Okay. So once you draw, you will come to know what is there, at least the headings. Try to draw the figure. Don't see it from the mobile. Is it finished? Amal, drawing has to be completed. That is, taking the picture has to be completed, not the photograph. It has to be available in your notes. Completed. Is it finished? Drawing is finished. Once it is done, just let me know. Okay. It is finished. Then we can move. Bro. Right. Right. So then next topic is our iterative waterfall model. Okay. So in iterative waterfall model, it is an extension of the classic waterfall model. Okay. So iterative waterfall model is the extension of your classic waterfall model. Whatever we have seen in the previous one, that is the extension for, sorry, this is the extension for your previous one. That is classical waterfall model. Incorporating the feedback paths to make the usable practice, that is practical software development projects. Okay. So what is included extra? Feedback is included extra in the iterative waterfall model or iterative model. So challenges with the classical waterfall model include hard to use in real world projects due to the lack of provisions for correcting errors in previous phases. So whatever the errors that we are having in the previous phases, we are not going to correct them. That is the drawback or challenge which we are having in this particular iterative model. So classical waterfall model is idealistic but impractical. So when you are speaking about the classical waterfall model, it is idealistic but it is not the one which is practically happening. Okay. So this is our iterative waterfall model diagram, where again you are having feasibility study, requirements analysis and specification, design, coding and testing, integration and system testing, maintenance. Okay. So what is the thing that is iterating? What is the thing that is iterating in iterative waterfall model? In iterative waterfall model, what is the thing that is iterating? So what is the role of customer in all these phases? Is it involved? At every stage, customer's role is involved or not involved? In iterative waterfall model, at every stage, customer's role is involved or not involved? Customer involved అయి ఉన్నారా? Not involved. So if it is not involved, then why there is a necessity for iterative waterfall model? Is customer involved from the beginning stage to the last stage? Check with your diagram. So what you are doing in the iterative waterfall model? So feasibility study you are doing. First step you are doing. That is done, completed. Next, what you are doing? Requirements analysis and specification. Right. So once the requirements analysis and specifications are done, then you are moving on to the design phase, coding and testing phase, integration and system testing, and maintenance. Right. So once the maintenance is there, so from maintenance, where we are moving, that is once the product is delivered or deployed to the customer, if you are getting any errors, where he is approaching, where he is approaching, where he is approaching, customer is approaching to company or manager where the product is being delivered. So manager, to whom he is asking? So if you are getting any errors after deployment, where the failure has come in, from where your failure is coming. So which is the team that is cleared all the errors and produced the project to the customer? What is the team who has given the product to the customer? Who has given the product to the customer? Sorry, product, who has delivered the product to the customer? Product ఎవరు డెలివర్ చేస్తారు? Engineers have developed and deployed the product to the customers. Very good. So in an organization, if the product is getting any sort of errors or maintenance issues, whom should we ask? That is the failure of which portion of engineers? Which portion of engineers? See, before the product is being delivered to the customer, what is the process that we are undertaking? What is the process that we are undertaking? What is the process that we are undertaking? Before deploying the product, what we are doing? We are testing, right? So when you are testing, your product is 100% perfect. When it is going into the market, your product is having some issues, right? So when the manager is getting questions from the maintenance, that is when the manager is getting questions from the customer, whom the manager is going to ask? whom the manager is going to ask? Manager ఎవరిని అడుగుతారు? So that is who has tested the product is going to ask the multiple number of questions. What you have seen, we are getting some errors. What is the test that you have done? That is, what are the tests that you have undergone? We are again getting some errors. Again, the customers are coming and complaining in a number of ways. What is the solution? Okay. So then this particular process is going to be undertaken. That is, the testers are going to test the model again, and again they are going to go for the code checking. Okay. So testers, they have tested successfully, and again they are changing. That is, they are sending the code for code recheck. What is the code that is being written by coding team and unit testing team? That is, what is the code that is being written by so and so person, and what are the tests that he has undergone? That part has to be tested. So once this is being also completed, they are again going back to the designing phase. What the designers has done and how it is coming with errors. Then this design person is also going to focus on the requirements gathering and analysis. So this is a iterative process. So if the errors are coming, that is mistakes are coming from the maintenance phase, they are going to focus on testers, coders, designers, and requirements gatherers. So like this, the process is going to be iterative one. Okay. So this is the picture, you can copy down again. You can take the picture as it is iterative waterfall model. Copy the what you can say, copy the diagram of iterative waterfall model. Make it little bit faster. Finished? Is it completed? Drawing into your notes, not taking the pictures. Is it finished? Is it completed? Drawing is finished. Shall we move on to the next topic? Yeah. Right. So the next model is V model, which is called as verification and validation. Okay. So whatever the things that we are keeping in all the phases are going to be verified and validated, then only they are going into the next phase, verification and validation. Okay. So the V model is a variant of waterfall model named for its visual appearance. Okay. It is going to appear as V shape. So the name is given as V model. So which is verification and validation. So it emphasizes on verification and validation activities throughout the development life cycle. So complete process, it is going to go for verification and validation. Whether it is valid or not, it is going to be kept with the help of this verification and validation. Okay. So it reduces the chance of bugs in work products. So what it is doing, it is reducing the chances of bugs. So whenever we are getting any kind of bugs, these are going to be reduced with the help of verification and validation. Okay. So it is suitable for safety critical software projects requiring high reliability. So when it is useful, so it is suitable for safety critical software projects requiring high reliability. Okay. So the phases involved in these are development phases, left half of the V model, and validation phases, right half of the V model. Right. So what are all those phases? Let us see. So we are having left side one set of phases, right side we are having another set of phases. Right. So in left side we are having requirements analysis and specification, system test design, then high level design, integration test design, coding and unit testing. For right side, we are having unit testing, again related to the coding and unit test design, integration testing, again related to the high level design and integration test design, and system testing, again it is related to the requirements analysis and specification and system unit testing. Okay. So this diagram also you can copy. So once it is done, we can go for the V model versus waterfall model, and then we can, if possible, we can close our session for today. Okay. So just copy the diagram of V model. Do it little bit faster. Copy the diagram. Okay. Don't discuss. No talkings. You can simply copy the diagram. So the process, whatever we are doing for the life cycle phases, the process would be same, but it is in V model. Left side, left cycle, we are going to have some phases. Right side, we are also going to have another set of phases. Finished? Copy it to downloads. Is it finished? Is it done from your end? Okay. If you're done from your end, just please check whatever we have seen so far with in your notes. Mellegama. Thanks. Done? Done with your drawing? Right. So again, we will go and compare with the V model with waterfall model. Okay. What are the features that are associated with SDLC model, that is waterfall model, and the V model? Right. So we have already pointed out that the V model can be considered to be an extension. So to whom it is extension? It is the extension of your waterfall model we are saying. So the difference is there you are having left side some values you are having, right side another set of values you are having in terms of testings only. Testings, gathering, and all those things. Okay. So that is the waterfall model. However, there are major differences between the two. Okay. So V model is different and the waterfall model is also different. However, they are having differences. So what are all these differences? Let us see right now. So as already mentioned, in contrast to the iterative waterfall model, where testing activities are confined to the testing phase only. Okay. So in waterfall model, we are confining our test cases or activities, testing activities to the testing phase only in waterfall model. So what we are doing in V shape, that is what we are doing in V model, are we restricting to only test phase? We are not restricting to only test phase. We are moving back to the all the testings, all the gatherings. So in the V model, testing activities are spread over the entire life, entire life cycle. Those activities are being spread. Okay. So as shown in figure, these two figures, you can see during the requirement specification phase, the system test suit design activity takes place. During the design phase, the integration test cases are designed, and during all the other phases, the various steps are going to be done. Okay. So let us see what are all those steps. So in requirements analysis and design, implementation, testing, evolution, all these are the phases of your waterfall model. When we are coming to the V model, we are having requirements design, system design, architectural design, module design, and coding. So this is happening in one set of activities. And the other set of activities are happening with unit testing. That is, once code is being tested by oneself, then it is going for integration testing, then it is going for system testing, and finally it is going for acceptance test. So in V model, we are going with both directions, starting from requirements gathering till the testing phase. And again, we are coming back to the coding phase with the help of all the directions. Okay. So system testing and system test and system design are happening simultaneously. So architectural design and unit test, that is integration test, are happening simultaneously. So module test and unit test are taking place together. So likewise, we are having multiple tests in V model, and we are having one phase after the other in the waterfall model. Okay. So then comes the advantages. So we are having some drawbacks in waterfall model. That's why we are moving on to the V model. So it should have some advantages because everyone expects better results from each and every model that we are choosing, right? So what are the advantages? Let us see. So parallel testing activities are possible in V model. So if you can see the previous diagram, so parallel testings are taking place. So architectural design is taking place, integration test is taking place. Both of these are taking place simultaneously. System design is taking place, system test is also taking place. Both are taking place simultaneously. Requirements design is taking place, acceptance test is also, sorry, requirements gathering is taking place, and acceptance test is taking place. So coming to here, module design is taking place and unit test is also taking place. So all these tests are taking place simultaneously. That is parallelly we could able to test each and every aspect. Okay, apart from requirements, we can check each and every aspect parallelly. That is the advantage over the here in V model. Okay, so we can also go for better quality test cases. We can also go for the better quality test cases with the help of V models. Okay, so these are all the few definitions and few points with respect to waterfall model, V model. Okay, so we have seen in the second part, so you have seen the life cycle, again software life cycle phases, then SDLC, then what else we have seen? Iterative waterfall model and waterfall model, V model, and the differences between your V model and waterfall model. Okay, so these are the concepts which we have covered in our second part. That is, after completing your first portion of your unit 1, we have seen these topics like software life cycle. So what do you mean by software life cycle? What do you mean by software life cycle? So the phases that the software is following throughout its life cycle, sorry, throughout its life phase is called your software life cycle. So how many phases will be there for software life cycle? 6 phases. Okay, what are those 6 phases? Feasibility study. So starting from, if you are saying from start feasibility study, So it is feasibility study, requirement specifications and gathering, then planning, designing, coding, testing, and maintenance. Okay. So if you are starting from communication phase, communication, planning, designing, then testing, that is, sorry, communication phase, planning phase, design, coding is also going to be under your testing, it's testing and deployment. Okay. So if you are starting from communication phase, you have to write like this. If you are starting from feasibility study, you have to like that. Okay. So then we have seen the SDLC. So what is the purpose? So to provide the structured approach for software development, we are going for the SDLCs, right? So and to ensure the quality, efficiency, and predictability, we are also going for the SDLC. Okay. So then we have seen the SDLC models. What are the various models that we are having? What are the various models that we are having in SDLC? Waterfall model, iterative model, spiral model, and V model. Okay. So out of which we have seen the, again we have seen the phases of SDLC like requirements, design, coding, testing, deployment, and maintenance. Then we have seen the benefits of SDLC models. Then we came to see the process versus methodology. What is the definition of process and what is the definition of methodology? And then we came to see the SDLC model, where we have seen the waterfall model first, then we have seen the iterative waterfall model, then we have seen the V model. So waterfall model we have seen, iterative waterfall model we have seen, then we have seen the V model. Then we have also seen the differences between your V model and waterfall model. Okay. So lot of topics are there. That is lot of headings, side headings, subside headings you will be getting in your subjects like SC. Okay. You have to remember all those things so that you can do it well in your exams. Okay. Shall we continue? Yes. Shall we go for the prototyping? Or in tomorrow's morning session, we can go for prototyping. So we are having next prototyping model, incremental model, evolutionary model, RAT model. So lot of models are waiting for us for tomorrow's morning. Okay. Ma. Still 33 are there. So we can cover all those topics in tomorrow's class. Meanwhile, you can check out with your notes. Okay.
తెలుసు ఆయన అన్ని కనుక్కోవాలి నీకు కావాలా దీపుకా దీపు అది ల్యాప్టాప్ ఎవరిదో తీసేసుకోండి